The musicians and their audience, they're making and hearing beautiful music together. An experiment conducted in Berlin shows that the brains of the performers and people in the audience start to act in harmony. But what parts of the brain are particularly active, and how can that be shown using a computer? Moritz Grosser-Wentrup specializes in those kinds of questions about the brain. At the Max Planck Institute in Tübingen, he's working on a common language that will allow the brain to communicate directly with the computer. He develops complex programs that enable computers to recognize and understand electrical signals from the brain.
First, the computer has to learn what the test subject's brain signals look like. Then the test subject needs even longer to learn to use this brain-computer interface. It's a give and take between computer and subject.
Not a single muscle has to be moved. Just thinking about an action is enough of a signal. After a little while, the test subject can move the point using only his thoughts. His brain cells are directing the computer, and he says it's fun.
When you see it working, it's amazing. You don't have to move anything, you just think, and something happens. It's fascinating.
Grosser-Wentrup wants to use this understanding of how the brain works to develop new treatments for medical disorders. He's even thinking about implanting computer chips in the brain.
I think we'll get to the point where patients who've had a stroke, for instance, will get replacement parts planted in their brain, or that damaged brain areas will be bypassed using chips. It's quite possible we could see that within the next 10 to 20 years.
He's already using robots to help stroke victims who have lost the use of an arm. This artificial arm is used for training purposes. The brain has to relearn how to turn the intention to do something into an actual command. The training may help rehabilitate damaged areas of the brain.
By synchronizing the intention to move with the actual movement, we hope to stimulate plasticity in the brain that will lead to better rehabilitation for our patients.
That process works best when the control signals come directly from the brain. That's why Grosser-Wentrup is working closely with surgeons at Tübingen's University Hospital. They specialize in planting super-thin probes or electrodes into the brain. The process is used in patients with diseases like Parkinson's, epilepsy, or tremor. Using the electrodes to provide small electrical stimuli, the doctors are able to control the activity of damaged brain cells. It's not clear exactly how it works, but it seems to be effective.
What we know is that when we stimulate this special part of the brain, we can actually suppress pathological brain activity that leads to people having involuntary tremors.
Scientists and doctors alike are hoping this ability to at once stimulate and monitor the brain will lead to great progress, and not just in treating illnesses. Researchers hope it will help them better understand how the brain turns an intention into an action. It's already possible to generate the intention artificially, like the one to move the fingers, for example.
Depending on what parts of the brain or what patterns you stimulate, you can create really complex thoughts. So when you stimulate certain areas, you can actually create the intention to do something. And that's quite mind-boggling.
A neurochip with human brain cells attached could play a major role in this work. This chip has 16,000 points of contact, a world record. It acts as a small computer that can monitor and stimulate. It's designed to be implanted in the human brain to help treat diseases. The idea of inserting a chip inside a human brain also opens up a new world of possibilities. Can we also improve the brain's capabilities? Can we implant images, thoughts, or even languages in the brain? Moritz Grosse-Ventrup says that's all science fiction, but he does say the research could make a huge difference in other ways.
I don't think it'll be long before we're able to pick up brain signals, transfer them to a computer, process them, and then feed them back into the brain. That could be a really useful way to treat a variety of diseases.
A direct line to someone else's brain is something we probably won't see anytime soon. But experiments like this one with music give us a chance to find out how the brain ticks and put that knowledge to good use.